everyone, welcome back to Zatu. My name is Blessing. Today we have Emily Seto, and she's going to go ahead and allow me to interview her today. It's going to be really cool. So could you go ahead and introduce yourself and tell us a little bit of what you do currently?
Hi, my name is Emily, and I'm a planetary protection and contamination control engineer at Honeybee Robotics. And my job is to prevent both forward and backward contamination of spacecraft to ensure that we preserve scientific integrity and that we can say that life exists on other planetary bodies. For example, for backward contamination, we want to make sure that when we bring back samples, we'll be protecting Earth from any potential contamination as well. And a lot of this work requires a background in microbiology, chemistry, and also engineering. So it's interesting because it's a marriage of all these fields of sciences, and it just makes a really cool career. So, the day in the life of a planetary protection and contamination control engineer is quite exciting. From the beginning of a mission, we're a part of the planning process up until the spacecraft launches. We get to know our hardware intimately, and we ensure that we meet all these cleanliness requirements throughout the process. Excuse me. So for part of my job working with engineers is to ensure that we meet these cleanliness standards, as I mentioned. For example, we do methods that reduce contamination, such as bakeouts, wiping down hardware, and then making sure that these bakeouts do not have materials that outgas and damage our hardware. And once it gets cleaned, we basically put on these bunny suits and we integrate it into the bigger spacecraft, and it lives in something called an ISO level clean room where nothing goes in and anything that comes out is filtered, and definitely no contamination. It's humidity, temperature controlled, and that's how we keep it clean. Also, what we do is go into the clean room and we sample and we pick up any type of spores or microbes that may be present on the spacecraft, and we take it back to our lab and we analyze it for something called spore formers, as I mentioned. And these spore formers are basically indestructible pods, which have a very hardy exterior, and it's a result of either human contamination or environmental contamination. Either way, we take it back and we analyze it and we store them and preserve them for future research. This summer, I was part of this campaign called the Mars 2020 ATLO team, where we worked from beginning to end, and this is the end portion where we watched the spacecraft launch. It was like watching our child go off to college. It was such a very emotional experience, but it was really cool seeing the spacecraft go all the way up until launch, and getting to sample the hardware that's going to another planetary body is definitely another plus. Another part of my job is also to conduct research, coming up with solutions to improve workflow and technology capabilities. This is probably one of my favorite things about being a PP&CC engineer. Most recently, I was a recipient of something called the ROSES proposal, which is a really big grant. And I was competing against a lot of seniors in my field and also applicants at JPL, which made it very nerve-wracking, but I was able to pull through, and I'm continuing to do this type of work and propose innovative solutions. Some upcoming activities at Honeybee, I'll be doing some field work. Honeybee Robotics is known for their drills and mining technology, and they'll be collecting samples from other planetary bodies using this technology. So I will be going to this program called HI-SEAS, which is a habitat on an isolated Mars-like site on Mauna Loa, and it's approximately 8,000 feet above sea level. But this is an extremely unique program because we'll be gowning up in astronaut gear and basically collecting lava tubes and analyzing them for microbes. And we'll get to go on these EVAs and pretend like we're on another planetary body. And additionally, we get to live in a habitat, which is basically a floor space that's about 1,200 square feet, and it provides a room for the crew members to sleep, to work in the kitchen. We have a laboratory, a bathroom, and a simulated airlock and a work area. So it's extremely exciting getting to basically live like an astronaut for 2 weeks.
That is honestly amazing. Like listening to every word you had to say was just awestruck, if that's a way to describe it. Just seeing how you blend with so many different careers in STEM within your own career role. So given the you explained about how you work a little bit with microbes, you work with engineers. What made you choose a career in STEM? What was your educational journey leading up to where you are today? And have you always had this type of career in mind in your
yeah so definitely I feel like the the path forward to this career was definitely very unconventional. But it started at a really young age. At the age of 4, I actually had kidney failure, and it affected both of my kidneys. And luckily, some doctors at the Children's Hospital of Los Angeles, they were able to save me. But from that event, I learned public health at a very young age, and I've been quite conscious about what I eat. And that's how I was introduced to public health early on. And then leading on to my career in college, I was actually looking for internships in infectious diseases, and I was able to volunteer at the UCI Medical Center, which was, just 20 minutes away. So that was really great that we had access to these types of programs at UCI. And my love for microbiology really did blossom while I was doing this internship. I was at a career fair that was hosted by UCI, and they brought in these public health microbiologists, and I reached out. They were able to offer me an internship, and I scored my first internship that way. And being able to work at the OC Public Health Microbiology Water Lab, I loved working near the beach, and I got to access and assess different water samples. So it was really a win-win situation for me. From there, I really did expand my connections and network, and I was introduced into my first job at Children's Hospital of Orange County, where I worked as a microbiologist. And from there, I was introduced to another job at the UCI Medical Center, and then I taught piano on the weekends. So it was really me working hard after college and really trying out different things, because I wasn't really sure what path I was going to take. I could have taken the research path, or I could have taken the diagnostic clinical side, but I really liked microbiology. I knew that in general. So after 2 years, I decided, working these 2 jobs are great, but I really want to further my career. So I did my master's abroad in Nottingham, England, where I specialized in clinical microbiology, and I specialized in spore formers, and that's what led me to my job at JPL. So there's the connection there with, the hardy microorganisms that survive in the clean room, and then the specialty in the hospitals where they have these spores that contaminate, hospitals, and patients get sick from them. So there's that crossroad there. And that's how I got into the field of planetary protection. But yeah, I think in a nutshell, I was extremely proactive. I did a lot of research. It wasn't, I just woke up one day and I just got into planetary protection. It was definitely like a very long path, and definitely very unconventional in comparison to other jobs. So I think all students need to be extremely proactive and do very thorough research before you invest in a career path.
Yeah, that's what I feel like a lot of students need to hear. No matter what career path they go into, research is always going to be key.
Definitely.
In career fields. So, as a female in STEM, have you ever felt like a outsider, in a male dominant field of study,
Yeah, definitely. Even though it's male dominated, there's definitely a lot of up and coming females in the field. And I have a lot of female colleagues who are very powerful and intelligent. So I don't think it's going to be a male dominated field for very long. I feel like I'm part of a very female-dominated science community on social media, such as Instagram, where we, support each other on our endeavors. And, on Instagram is such a great platform for that. And not a lot of people know about that. So I think getting the word out that, social media is a great platform for that. I have a lot of women I look up to as well. For example, the Planetary Protection Officer of NASA, and her name's Lisa Pratt, and she's such a great role model. And I look up to other scientists such as Kate Rubins, who is the first person to sequence DNA in space. She's also a microbiologist, which is pretty inspiring. I was lucky enough to host her, and she came to JPL and she gave a talk about her career. And, she's actually in the ISS in the International Space Station right now, doing some experiments. So that was really cool that she got to go back again to do these experiments. So yeah, I think it's definitely a male dominated field, but I think there's up and coming opportunities for females as well. And I think social media is the perfect place to build our community.
That's really inspiring to hear, to know that we're going towards the right direction, especially making, STEM more inclusive of, different genders, instead of making it, more dominant of one over the other. So my last question for you is, what advice would you offer to other students watching now that hope to do what you're doing today?
Yeah, I would say, try to stay motivated, try to stay positive, proactive, and curious. Definitely do your research. There's many applications that your field can contribute to. For example, during my time at JPL, I've met people who specialize in origami, and that was their job at JPL, was to fold and figure out how to creatively configure hardware so that we can pack it efficiently in the launch vehicle before launch. So, I mean, there's an application for everything. I've met food scientists who are working to develop special formulas for astronauts who are going to long-term missions to Mars and figuring out formulations so that the foods don't spoil. I mean, the opportunities are endless. I think, if there's something that you want to do, definitely go out and do it. And if there's anything that you take away from my talk today, just remember that, you're the pilot and you basically control how far you go. It's just, you have to keep the right mindset.
Amazing advice. Thank you so much again, for doing this interview with Seto. But that will conclude our interview today. Thank you.
Awesome. Thank you.